MT2-Miles.
Pictures. What else? Come on, Aaron.
Maybe spread of disease.
Disease. What are some other things that maybe the animal can't control?
Natural disasters.
Natural disasters, good job. What if you were a plant? What do you think you would need?
Light.
Yes, sunlight. And I'm looking for one more, something that, actually two more. They're basic things everybody needs to survive. Without it, we would all probably die.
Water.
Water. And maybe one more that we need. So the plant needs sunlight to live. We would probably need space, habitat. I'm looking for oxygen, since we all need to breathe. It's kind of a basic one that we all tend to overlook, but that one will definitely come in here too. So these would be examples of limiting factors, which are factors that we need to live. And the limiting factor is any biotic or abiotic factor that restricts the existence, numbers, reproduction, or distribution of organisms in an environment. And basically what this means is these are those factors that come into play in environments that will cause population numbers to decrease if they get out of control. This is what's going to limit your population. And I put these into two categories, as you can see. And this is going to represent your biotic, B, and abiotic limiting factors. And these are obviously not all of them. There are some more. But your abiotic factors are going to be factors that really aren't related to organisms interacting with each other. That makes sense? Because in the biotic you have food, habitat, predators. These are all things that involve the organisms interacting with the other organisms in that population. The abiotic are going to be things that really aren't in their control. They're more of the environmental factors. So I guess non-living, if you want to think about that, for abiotic. And biotic are going to be your living factors that are going to affect your population. And here's just a little illustration of some limiting factors. You have your disease and parasites. Obviously, if an animal gets a disease or a parasite, they may become sickly, and that will cause some population numbers to decrease. And then you have accidents. And I'm sure we've all seen on the side of the road armadillos or raccoons that have been run over. And the funny thing about armadillos is they have this, I guess, instinct or natural reaction to when they're scared. They like to jump up in the air, which is fine if you're in the woods. But if you're an armadillo in the middle of the street and a car is coming and you get scared, jumping up in the air is really going to limit their numbers because they're going to get squashed. So we have our limiting factors. Now, range of tolerance is kind of an interesting concept in that some animals have developed these adaptations to tolerate environments better, or just kind of outsmart limiting factors, if you want to think of it that way. And this picture is of an Arctic ground squirrel. And this guy's pretty interesting, and that is the only warm-blooded mammal that is known to survive without freezing a body temperature that is below freezing. So as you remember from our previous lectures, we were talking about biomes. This guy will be found in the tundra. And as you know, the tundra has the permafrost and it's a very cold and freezing place. This little squirrel can survive up there and actually freeze without freezing. It can survive these freezing body temperatures for actually more than an hour. So this guy has a pretty interesting range of tolerance for his environment, adding that limiting factor that would be a climate in this situation. So limiting factors, we have two types. population density, which is how many organisms you're going to have in a given area, we will have our density-dependent factors. And going back to the example of our class as a forest and we're all bears, if there are, say there's 5 of us in here, and Aaron gets sick. The fact that there's 5 of us, our chances of also getting sick are going to be a lot smaller, say if there were 50 bears in this classroom, because we're all going to be crammed in and more close together. So you can see that this factor, such as disease, is a density-dependent factor, that the more animals we have in an area, disease will have more of an effect on the population. So as these density-dependent factors, they have an increasing effect as populations increase. So obviously more animals in the area will be less food. You may have more diseases coming into play. These are all dependent on the number of creatures we have in that environment. And so with density-dependent factors, we also have density-independent limiting factors. And these are factors that really we're not going to depend on population numbers. So again, using the scenario where we're all bears, say we have a forest fire in our classroom, no matter how many of us there are in this forest, if this is a large enough fire, we're all going to die. So you can see that density-independent factors really do not take into account the numbers of organisms in a population. These are going to be independent, and these can be natural disasters will have a large effect on populations regardless of population size, humans destroying habitat, and so on. So again, density-dependent factors will depend on the number of organisms in the environment and will increase with increasing populations. And density-independent factors are going to have devastating effects across population regardless of their numbers. So we are going to wrap up for today, and we will do an activity for the end of this class, and we'll finish our